The 76 B-52s in service today comprise nearly one-half of today's total number of Air Force bombers and will continue to serve as the backbone of the nuclear and conventional bomber force for decades to come. According to congressional testimony by General Robin Rand, commander of Air Force Global Strike Command, I anticipate the B-52 will remain a key element of our bomber force beyond 2050. It is paramount to invest resources into this aircraft now to keep it more viable for the next 30 years. But how do you keep an aircraft viable and mission-ready for so many years? Through modernization. Today, the Air Force is in the process of modernizing the communications and weapons capabilities of the B-52, as well as installing a new radar. The final crucial element to this modernization is to replace the engines. Not only are new engines necessary, they will provide enormous economic benefits, creating billions of dollars of savings in sustainment and fuel over the remaining life of the aircraft. The fuel efficiency would also significantly enhance the operational capabilities of the aircraft. A 40% increase in range or increased time over the battlefield provides for greater mission flexibility, as well as freeing up tanker assets for other missions. And while not normally perceived as an element of a military program, the environmental benefits in terms of carbon footprint and noise reduction are profound. Some have suggested that the original engines just need to be refurbished. This option would only slightly reduce some of the issues facing the propulsion system and not achieve any of the other benefits a re-engine provides. Let's take a closer look at each of these and see just how much value a B-52 re-engine program would provide to the Air Force, the U.S. warfighter, and the taxpayer. Over time, improvements in technology have produced engines that are easier to sustain, more fuel efficient, and more reliable. For the B-52, a re-engine program using this new technology will lead to a dramatic decrease in cost of ownership. The cost to operate and sustain the B-52 engines has grown at an alarming rate. In 1996, the cost to overhaul a single engine was $230,000. Today, that same engine overhaul now costs $2 million. Adding in growth for fuel and other engine maintenance expenses, the cost to sustain the engines really begins to rise. Likewise, finding spare parts for an engine that has been out of production for decades will only become more difficult. Due to improvements in engine technology, a new engine installed today would not need to be overhauled, ever, for the projected life of the B-52. This program will result in more than $10 billion in taxpayer savings between now and 2050. This is money that the Air Force can use for other funding priorities, from readiness to recapitalization. A re-engined B-52 would be able to take advantage of the increase in fuel efficiency that a modern jet engine provides. This will result in enormous operational benefits in terms of range and orbit time increases. On average, a modern engine in the same class as the one used on the B-52 is over 30% more fuel efficient. This translates to an increase in range or in the amount of time the aircraft can stay on station over the battlefield. This increase allows for tremendous flexibility to the war planner in how to utilize the B-52. Additionally, this added range will result in a decreased demand for tanker support, freeing up this limited resource to other warfighter requirements. While not a consideration when the B-52's current engine was built, the environmental impact of a jet engine is extremely important today. The current fleet may only have 76 aircraft, but the carbon footprint of each of its 8 engines adds up to a measurable impact. New engines would reduce that footprint to less than 5% of current engines. Likewise, the amount of noise produced by the operation of a B-52 is extraordinary and could be reduced by a factor of 30 with the introduction of new engines. This is a safety consideration for aircrew and ground crew, as well as a quality of life benefit for anyone living near the base of operations. A B-52 re-engine program gives the Air Force a complete solution for modernizing the aircraft's propulsion system. As time has gone on, engine-related issues have had an increasingly negative impact on the availability of the aircraft and has cost the Air Force more and more money. A re-engine program for the B52 would replace the engine core as well as the struts, nacelles, fairings, engine accessories, and engine instruments. A refurbishment program would only address parts of the engine core. A refurbishment will not address the billions of dollars in other engine maintenance or generate savings from fuel efficiency, nor will it enhance operational effectiveness or reduce environmental impact. Providing billions in future savings, enormous operational benefits to the warfighter, and environmental enhancements that serve us all, the only choice is to embark on an engine replacement program for the B52.
The 804 Authority, I think, suffers from misapprehension based on the original intent of the authority vice how it's being used now. There were a variety of creators. Some of them viewed it as a wholesale overhaul of the acquisition system because you can do that. The authority is that broad. Others thought it should be a very tailored thing to use for programs like hypersonics or advanced weapons, advanced sensors, but not something you would use for a normal major program. My view is that it's somewhere in between. It lets you get on contract a year and a half earlier for an MDAP. And we found that for a variety of MDAPs, including the B52 re-engine, you can use that year and a half to great effect. It's much better to be on contract with industry and working from day one than sitting around twiddling your thumbs. In the case of B52 re-engine, we are using that time to do digital engineering for the engine pod integration. So we have all three industry vendors on contract. We have Boeing on contract. They are working together as part of this source selection. They will deliver their digital prototype to us by October. We would normally not even be on contract, and already we have a deliverable that will help us understand, does the vendor understand the challenges of integration? Are they able to keep the center of gravity and the fluid flow around the power pod? Are they able to keep that the same? We will have that earlier. Because we have a year and a half, we can go from virtual prototyping into physical prototyping. So we'll select a vendor, and then we'll do round two, which is you gave us your digital twin, now give us the physical twin. Show us you can do it in the real world. And then we'll down select and we'll award contract and move to the integration side of the program, so move into the production side. So what I view in this program, because I have an extra year and a half, I can spend more time in EMD, engineering, manufacturing, and development. I can take on more engineering rigor and retire risk faster than I would if I was denied that time and trying to meet a near-term operational need. In the case of the B52, the TF-33 engine has been flown hard. It is an old engine. We have maintainers up at places like Minot that are doing heroes work to piece these engines back together. The depot is doing heroes work to try to do maintenance overhaul with a supply chain that is gone. So we are at high risk for keeping that engine far into the future. And so when my warfighter says I need a new engine, and I have one path, which is the 804 path, which I can start a year and a half faster than I could the traditional path, I can't tell that warfighter I'm going slow because that's what others think is the best path. I can go fast, but I can do it with rigor and discipline. And to close off, why I don't think it's a wholesale overhaul of the acquisition system is that we do all of the same documentation we would have in a traditional program. We just do it after we award contract. So we get the benefit of jump starting, but we still do all the discipline of documentation. And I think the pushback we've seen from the Hill is a misunderstanding that we still do the rigor. I'm not sure that the entire department is taking that approach, but the Air Force is. So it still is the same as the traditional acquisition, just faster and with more time to do design. And you know this as well as I do, Valerie. Most of the programs that have been the cautionary tales in acquisition left EMD too soon. So the opportunity to inject a year and a half into every program, it's an opportunity we have to take.
Welcome to the Defense and Aerospace Report. I'm Vaga Muradian here in Orlando, Florida for the Air Force Association's annual Air Warfare Symposium, the #1 winter gathering of U.S. Air Force leaders, industry executives, analysts, thought leaders, and media here in Florida. Our coverage here is sponsored by L3 Technologies and Leonardo DRS, and we're over here on the Rolls-Royce stand to talk to Craig McVeigh, Senior Vice President for Strategic Systems at Rolls-Royce. Sir, it's always a pleasure seeing you.
Yep.
Good to catch up. Having a good show so far?
Excellent show. Yeah, we've had quite a bit of exposure, good opportunities to tell our story with the Air Force leadership, and certainly with some of the up-and-coming Air Force leadership, the young junior officers, the men and women that will be leading us tomorrow, so it's a big deal.
Absolutely outstanding. We had a great conversation with General Spencer, and it's really different. The character of this event, for example, compared with Airspace and Cyber, which is much more general officer, colonel grade, whereas here you see a lot of enlisted folks, you see a lot of NCOs, and you see a lot of junior officers.
And university students as well. I mean, it's a great opportunity to tell them about Rolls-Royce, tell them our story, and tell them how we're contributing certainly to the Department of Defense and more specifically to the Air Force.
So as stand displays go, you guys apparently are the winner. You guys have a half-scale B52 engine nacelle, absolutely fantastic. But you know, obviously, it's one of the more important competitions that are going on. The Air Force has talked roughly about $9 billion in terms of re-engineering the B-52 fleet. Right now, it's Pratt & Whitney TF-33 powered. Once upon a time, it powered almost everything in the Air Force. It was a foundational engine, whether it was for 141s or KC-135s. Let's talk a little bit about the competition and where it stands, right? Because you're looking at a study getting started next week. So from your perspective, where are we? And more importantly, you and I were talking before this, how the program, the Air Force really wants to use this program to do things differently. It's one of the programs that Dr. Roper has focused on. Talk to us a little bit about what's going to be happening and where you think, because you had an innovative take on how you think this is going to be playing out.
Yeah, so first of all, I would say the Air Force is pursuing in production new commercial off-the-shelf engine solution for replacement of the TF-33. That in and of itself is unique. I mean, we're talking about part of the nuclear triad, this nuclear bomber that has been in operation now for several decades, with the expectation that it's going to fly for several more decades. But the idea is to go out and identify the right commercial off-the-shelf engine that is available, that meets all the requirements, can be easily integrated, well I say easily, but it will be integrated into the B-52 platform as a system, an entire system, and can accommodate all the requirements that that platform will need in the way of power offtake, in the way of thrust, and so forth, time on wing, proven reliability, and I'll talk to that in a minute. So for Rolls-Royce's part, we're offering the F-130, and the F-130 entered into service. It's a commercial engine that entered into service back in the 2012 timeframe, and it's part of a much larger family of engines. The F-130 that's flying today on the Air Force, it's on the E-11 Bacon aircraft, it's on the C-37 aircraft, it's going to be on the ECX aircraft, or Gulfstream products. The E-11, of course, is Bombardier, but those are platforms that are flying it now, and that family has got over 22 million hours of operational time, flight time. That is proven reliability. And for this engine, it's, as I said, been in a production in existence now for over 6 years. It's got over 700,000 plus hours on it. So that's the kind of thing that we think is going to be important to the Air Force, is something that works. The second thing I would say is that it's what we would call the perfect fit. If you were to ask me to build an engine today to provide for the B-52, and I would look at the specs and what's required for that platform so that it pretty much meets the requirements in thrust and so forth, I would have built that engine. I mean, it's got, as far as the fan diameter, the current thrust, the capabilities, albeit it's got a FADEC, electronic engine control capability, as opposed to a hydromechanical fuel control for the TF-33. But those kinds of requirements are certainly going to be very, very competitive for this offering. And so we're excited about that. You touched on it a moment ago, and that was this rapid prototyping, Section 804. We've listened very clearly to the Secretary of the Air Force, to Dr. Roper as the Surface Acquisition Executive, and certainly to the B-52 SPO, propulsion SPO. They're very focused on a rapid prototyping solution so that they can do what they need to do as far as identifying it, developing it, and get it into service in a short period of time, certainly shorter than the more traditional approach that in acquisition that we've seen in the past. What's unique about this particular effort, as I mentioned to you earlier, is this is engine company against engine company. This doesn't involve primes and so forth. This is right. This is up against what do you got How can you integrate it? What's your solution? And is it the right one? And Dr. Roper's idea is, let's use rapid prototyping to identify that solution early. Let's find it, let's get after it, and let's get it into the system.
You know, it is right back to the future, right? Or future to the back, or however you want to put it, right? This is an old-timey competition where you're getting the engine suppliers together and not letting the prime do the selecting of it. The service is going to select it, you're going to integrate it on. You mentioned something about electromechanical controls. One, that's what the technology allowed at the time for hydromechanical, excuse me. But that was also a nuclear requirement to make sure that whatever happens in a nuclear blast in an EMP environment, the aircraft was still going to operate. And there's a little bit of a debate and discussion about whether something that has fully digital flight controls is going to be acceptable. How does that work? Because the B-52 is going to remain a swing roll airplane that is going to span the nuclear mission to the conventional mission. What do you need to hear from the Air Force at this point? Because my understanding is the information that you're getting is coming from the contractor, which is commercially available, as opposed to something which is coming from the Air Force. Do you have any sense at this point what the state of discussion is on that requirement, which could be a very, very important requirement at the end of the day?
Well, while we're still waiting to gain a little bit more granularity in the specific nuclear requirements that are coming out of the SPO, we do know that there are engines operating today on the bomber fleet, whether it's a B-1, a B-2, and certainly the one in production now, the B-21, all have nuclear hardening requirements, cyber requirements. And so it's clearly a situation of making sure that, in receiving from the Air Force the specific requirements that they want with regard to nuclear hardening. All of the offerings for this engine competition are commercial engines. All of them will require some degree of nuclear hardening, whether it's the FADEC, it's the any of the controls or any of the things that are associated with it. They're going to require some type of nuclear hardening, and so all we are anxious to see is the actual requirement captured, so that we can get after it. We know rapid prototyping very well. We've done that for a long time. We are very capable in digital engineering, as far as design and certainly in the manufacturing side. So we're very confident that we can accommodate what those requirements will be. It's just making sure that we hear what the Air Force wants and then we go after it. All of these commercial engines are going to require some degree of change.
Let me also ask you time on wing, but also fuel burn efficiency. At this point, what can you tell us in terms of what the characteristics or the selling points or the efficiencies you think you guys are going to be delivering with the F-130?
Well, let me just say it will be very competitive. When we look at the TF-33 today, and it's been quite the workhorse for the B-52 fleet, our offering is going to be an order of magnitude significantly better, and you would expect that when you look at some of the engineering that's gone into the fan, the compressor, and certainly the turbine section. These are 21st century engines. There's an expectation, of course, that you realize considerable efficiencies in the way of specific fuel consumption. So we know all the offerings are going to be competitive. We believe ours will be. Where do we break out as far as the others go? It could be in digital design, it could be in digital manufacturing. Certainly it's in proven reliability because this comes from a family of engines and it's currently in the inventory. So we think that's pretty compelling.
Craig, thanks very much. It's always a pleasure talking to you. Best of luck in the competition. It's certainly a competitive field. 3 companies that know engines really well. You guys, obviously GE and Pratt & Whitney, so it's going to be fascinating. And you think the Air Force is going to stay on its down select decision, which is next year? Well,
when we look at the Air Force schedule, we know that we would expect anyway some type of a draft RFP to come out later on in this year. But we also know that there's a rapid prototyping activity that's going on, and that certainly gives Dr. Roper and General Collins at the PEO level, it gives those gentlemen an opportunity to explore what engines are really out the front runners and how they would go after them. So we think we're very well positioned to compete in that regard. We're certainly going to be positioned when it comes time for source selection.
Craig McVeigh, thanks very much again, sir.
My pleasure. Take care.